Okay, so pulling a couple of examples of complex number problems out of the book, to help go along with our assignment today. Let's talk about, I pulled number 18 out, simplify. And it says simplify each expression, and it is the binomial 2 plus 4i plus the binomial 4 minus I. So as we look at this, we're going to combine like terms. So remember, we combine our imaginary units and we combine our real units. So I have 2 plus 4 is going to give me 6, and then I have 4i minus I, and again that is 4i minus I, which is 3i. So 6 plus 3i. Now looking at number 2, pulling that example out there, or I'm sorry, 21, we had 12 plus 5i minus 2 minus I. And when combining these, I wanted to create the addition, and then in addition, I would, by multiplying that times a negative, I multiply everything times a negative. So it went from a minus to a plus. This went from positive 2 to negative 2, and this went from minus I to a positive I. So when I rewrite that, I'm going to get 12 plus 5i minus 2, right? Minus 2, and then plus I, combining my real values to 12 and negative 2, which gives me 10, and then my imaginary units 5 and 1, which gives me 6i. So here's my answer, 10 plus 6i. Okay, additional problems. Again, solving, this one is find all solutions, and I went ahead and took one of the more difficult ones of the bunch, because here, in order to use the quadratic formula to factor this, to solve it, we're going to need to multiply it and do some inverse operations to get it into the standard form of ax squared plus bx plus c equals 0. So what I've done here is, beginning off, I've multiplied 2x times x minus 3, and that gives me 2x squared minus 6x equals negative 5. Do my inverse operations here, and then of course add 5 to both sides, so I end up with 2x squared minus 6x plus 5 equals 0. Now that I have standard form, I'm able to come up with my a, b, and c values. Taking in mind here that your b value is negative, so as we populate our equation, our formula, we have a negative b, so negative times a negative is going to give us ultimately a positive. But I go ahead and have over here, I have negative b, negative 6, minus negative 6, plus or minus the square root of negative 6 squared, minus 4 times 2 times 5, all over 2 times 2. I've just replaced all my a, b's, and c values. Simplifying, again, negative times a negative becomes a positive, so I have positive 6 plus or minus the square root of 36 minus 40 over 4. Simplifying, I have 6 plus or minus the square root of negative 4 over 4, and then we know, remember that the square root of negative 4 is the same thing as the square root of negative 1 times 4, which we learned that the square root of negative 1 is going to be I, the square root of 4 is going to be 2, so we have 2i. So there you go, that's where that 2i came from. So 6 plus or minus 2i over 4. I went ahead and embraced the fraction here. I went ahead and divided the common denominator up, split the common denominator up so you can see what's going on here. As we simplify 6 over 4 to 3 halves, plus or minus 2i over 4, which is going to be 1i over 2, and then splitting up my plus and minus answers, I have 3 halves plus I over 2, or 3 halves minus I over 2. Those are my two possible answers. both of them imaginary or complex, actually, not real numbers.